Welcome to day 29 of our Python journey. Today we are diving into NumPy, an essential library for numerical computing in Python. We will be covering array creation, slicing, and indexing, along with some key operations that make NumPy so powerful. Let's start with an overview of NumPy. NumPy stands for Numerical Python and is the foundational library for numerical computing. It enables you to work with multidimensional arrays and matrices. The best part, NumPy is highly efficient, meaning you can perform mathematical operations on arrays quickly and easily, even with large datasets. This makes it an essential tool for tasks in data analysis and scientific computing. To get started with NumPy, we first need to create arrays. An array is essentially a grid of values. And in NumPy, we can create a one-dimensional array as shown here. Notice how we use the np.array function to create the array. You can also create 2D arrays, which are simply arrays of arrays, like the example shown here with 2 rows and 3 columns. Now let's talk about slicing and indexing. This is a way to access and manipulate specific elements in an array. In our first example, we are accessing the first element of the 1D array. Similarly, in a 2D array, we can access specific rows and columns. With slicing, we can extract a portion of an array, such as elements from index 1 to 3. This flexibility makes NumPy arrays easy to work with no matter the dimensions. When working with multidimensional arrays, slicing becomes even more powerful. For example, we can select multiple rows and a specific column at once, like this today array slicing example. Another cool feature in NumPy is Boolean indexing. Here we filter the array to only show elements greater than 3. This allows us to quickly isolate elements that meet specific conditions. Next, let's explore array operations. One of NumPy's strengths is its ability to perform element-wise operations on arrays. This means you can add, subtract, multiply, and divide all elements in an array with just one line of code. For example, adding 5 to every element in the array or multiplying every element by 2. This makes it easy to perform mathematical operations on large datasets quickly. Another useful feature in NumPy is array reshaping. This allows you to change the dimensions of an array without changing the data inside it. In this example, we reshape a 1D array of 6 elements into a 2D array with 2 rows and 3 columns. We can also flatten multi-dimensional arrays back into 1D arrays using the flatten method. NumPy also offers several functions to make array creation easier. You can create an array of zeros or ones using arrange to create arrays with evenly spaced values, or even generate arrays with linearly spaced numbers using linspace. These functions are helpful when you need arrays of specific shapes or values for computations. Now it's time to practice. I encourage you to try the following exercises. Create a 1D array and access its first and last elements. Reshape a 1D array into a 2D array. Slice a 2D array into to extract specific rows and columns. Perform element-wise operations on an array. Filter an array based on a condition like values greater than 10. These exercises will help solidify your understanding of NumPy. To wrap things up, we have learned that NumPy is a powerful tool for creating and manipulating arrays. We explored how to create arrays, slice and index them, and perform mathematical operations. NumPy is efficient and makes working with large datasets and numerical computations much faster. Now we have the foundation to use NumPy for a variety of tasks from data analysis to machine learning. Welcome to today's session on data manipulation with pandas. In this lesson, we will explore data frames, perform data cleaning, and divide and dive into basic data manipulation techniques that will help you analyze and manipulate data effectively using Python. Let's begin by understanding data frames. A data frame is a powerful 2D labeled data structure similar to a table or a spreadsheet and is one of the core structures in pandas. You can create a data frame from a dictionary of lists. For example, a simple dataset of name and age can be turned into a data frame using the pd.dataframe method. Alternatively, we can also load data from external files like CSV files using the pd.readCSV function. Now, let's take a look at how we can explore data frames. You can display the first few rows of a data frame using the head method. To get information about the data frame, including the data types and any missing values, use the info method. And for statistical summaries of the numerical columns, the describe function will give you insights into the data, such as the mean, standard deviation, and more. Next, let's dive into data cleaning. It's common to encounter missing data in real-world datasets. You can identify missing data using the isNull method. If you want to fill missing values, the fillNA method is your friend. For example, filling missing ages with the main value of the age column. If you prefer to remove rows with missing data, the dropNA method can do that as well. Data transformation is also essential in cleaning. Sometimes you need to rename columns to make them more meaningful, which can be done using the rename method. Additionally, you need to change the data types of certain columns, such as converting the age column to a float. You can also add new columns to your data frame. For example, adding a new column that calculates a future value or modifies existing data. With a clean data frame in hand, let's explore how to filter and select data. To select specific columns, you can access them by using the column name like df age. To filter rows, you can use a conditional statement. For example, selecting only rows where the age is greater than 30. You can also use the log function for more complex filtering and conditional assignments like marking people over 30 as senior. Now let's discuss sorting and aggregating data. To sort data, we can use the sort values method. For example, sorting by age in descending order. You can also sort by multiple columns, for example by age and then by name. For aggregating data, we often group data by certain categories. The group by method allows us to group the data and perform operations like calculating the mean age of each group. Let's now put these concepts into action with a practical example. Imagine we have a CSV file containing some data. We can load the file into a data frame using pd.readCSV. Once loaded, we check for missing values using the isNull.sum method. We then fill missing values or drop rows with missing data. This is a crucial step before doing any further analysis or transformation. Continuing with the example, we may want to perform data manipulation, such as adding a new column that categorizes people as young or old based on their age. Finally, after cleaning and manipulating the data, we can save the cleaned data frame back to a CSV file using the toCSV method. Once you have mastered basic data manipulation, there are additional topics worth exploring. You can learn how to merge multiple data frames using the merge function. Another useful technique is creating pivot tables to summarize your data. Finally, pandas also offer robust tools for handling time series data through pd.toTime, toDateTime, and resample methods. To conclude, today we explored the core functionalities of pandas for data manipulation. You learned how to create and exploit data frames, clean data, and perform common manipulations like filtering, sorting, and aggregation. Remember, the ability to manipulate data effectively is an is an essential skill for any data analysis or data science task. Keep practicing, and soon you will be comfortable using pandas to work with complex datasets. Welcome to day 31 of our Python for Data Science course. In this section, we will dive into data visualization with Matplotlib, a powerful library used to create static, animated, and interactive visualization. In this session, I will be guiding you. Let's begin by understanding what Matplotlib is. Matplotlib is a Python library that allows us to create various types of visualizations, from simple line plots to more advanced plots like 3D and animated graphs. The key component of Matplotlib is the pyplot module, which provides MATLAB-like functions for plotting. First up, we have the line plot. A line plot is used to display data as a series of points connected by straight lines. This type of plot is particularly useful when we want to visualize trends over time or in continuous data. Here's a simple example. We have values for x and y, and we use the plot function to plot them. Next, we move on to bar plots. Bar plots are excellent for comparing discrete categories. Each bar represents a different category or value. In the fourth example here, we are comparing the sales of four categories, represented as bars. Another important plot is the scatter plot. Scatter plots help us show the relationship between two continuous variables. In this example, we plot x and y values as points on the graph. Each point represents a single observation, making scatter plots great for identifying patterns or correlations in data. To make our plots more informative, we can add titles and labels. By adding a title to the plot and labeling the x and y axes, we make the plot much clearer for anyone viewing it. Here's how we do it with the title, x label, and y label functions. We can further enhance our plots by adding a grid for better readability and legends to explain what each line or data series represents. In this example, we are plotting two lines and adding a grid as well as a legend to identify the lines. Customization does not end with labels and legends. We can also control the color, line styles, and markers in our plots. This is useful when we want to distinguish between multiple lines or emphasize certain data points. In this example, we change the line style to dashed and use circular markers. Sometimes we may want to display multiple plots within a single figure. This is where subplots come in handy. Subplots allow us to create a grid of plots so we can compare multiple data visualizations side by side. Here we create a one row, two column subplot to show a line plot and a scatter plot together. Let's look at some more advanced customizations. Histograms are used to display the distribution of data, and pie charts are great for visualizing proportions. In the example, we plot a histogram to show the distribution of data points and a pie chart to visualize the percentage breakdown of categories. Once we have customized our plots, we often want to save them for later use. Matplotlib allows us to save our plots as images. Using the savefig function, we can save our plots in various formats like PNG, JPG, or SVG. Now let's take a look at some mini project ideas. You can practice what you have learned by creating your own visualizations. For example, you could create a line plot to visualize stock market trends, a bar plot to compare sales of different products, or a scatter plot to analyze the relationship between temperature and humidity. To summarize, today we covered the basics of data visualization with Matplotlib. We learned how to create line, bar, and scatter plots and how to customize them with titles, labels, grids, and colors. We also explored advanced customizations like histograms, pie charts, and subplots. As your next step, try creating your own plots and experiment with different datasets. Happy coding! Welcome to day 32 of our course on Python. Today we will be diving into the world of databases with a focus on SQLite. We will learn how to set up and perform CRUD operations using Python's SQLite 3 module. Let's start by understanding what SQLite is. SQLite is a lightweight, serverless, and self-contained SQL database engine. It's designed for small to medium-sized applications and stores data in a single file, making it easy to distribute. Its simplicity makes it perfect for local databases and testing purposes. In Python, SQLite integrates seamlessly through the SQL3 module. To set up SQLite in Python, first we need to import the SQLite 3 module. Then we connect to a database using SQLite3.connect. If the database file does not exist, it will be created automatically. Once connected, we create a cursor object using con.cursor, which allows us to execute SQL commands. Now let's create a table in SQLite. We can use the create table SQL statement. Here's an example of creating a student table with 3 columns: ID, name, and age. The ID column is primary key, meaning it's unique for each record. If the table does not exist, we can add if not exist to avoid errors. Next, let's look at how to insert data into our SQLite database. To insert a single record, we use the insert into SQL command. We can also insert multiple records at once using execute many. After making changes, Don't forget to commit the changes to save them using can.commit. To read data from the database, we use the select query. The select star command retrieves all the rows from a table. If we want to filter data, we can use the where clause. For example, we can query all students older than 21 by using select star from students where age is greater than 21. To update data in the database, we use the update query. For example, if we want to update the age of a student, we use the set keyword followed by the new value. In this case, we are setting the age to 25 for a student named John Doe. As always, remember to commit the changes with can.commit. If you need to delete records from the database, you can use the delete query. Here we are deleting a record where the name is John Doe. After deleting, commit the changes to ensure they are saved to the database. Once you have finished working with the database, it's important to close the connection to free up resources. We do this using the con.close command. Always close the connection after performing operations to ensure everything is properly cleaned up. Let's go over some best practices when using SQLite. First, always use con.commit after making changes to ensure they are saved. Second, use parameterized queries to prevent SQL injection, a common security vulnerability. And finally, consider using with statements to automatically handle the connection, which ensures it gets properly closed even if an error occurs. For your practical exercise, try building a bookstore database. Create tables for books, customers, and orders. Implement CRUD operations for each table, and use real-world examples like book titles, prices, and customer information. To learn more about SQLite and SQL, I encourage you to check out the official SQLite documentation and online SQL tutorials. These resources will deepen your understanding of database management and SQL syntax. That concludes day 32, where we explored SQLite and how to perform basic database operations with Python. Keep practicing these concepts and you will be well on your way to mastering databases. Welcome to today's presentation on web scraping with Beautiful Soup. In this session, we will explore how to extract data from websites using Python, especially with Beautiful Soup library. Let's get started. Web scraping is the process of extracting data from websites for analysis. It's useful for a variety of purposes, such as tracking prices, gathering news, or collecting research data. By automating this process, we can save a lot of time that would otherwise be spent on manual data collection. To perform web scraping, we use two primary libraries, Requests and Beautiful Soup. The Requests library allows us to send HTTP requests to websites, retrieving the HTML content of web pages. Beautiful Soup is a powerful tool that helps us parse this HTML content, making it easy to extract relevant data. Sometimes we also use the LXML library for faster parsing. Before starting, we need to install the necessary libraries. You can do this using pip. Simply type pip install requests Beautiful Soup 4 to install Requests and Beautiful Soup. For additional speed, you can install LXML with pip install LXML. Once the libraries are installed, we can send HTTP requests to fetch a web page. For example, we use the request library to send a GET request to a URL and then access the HTML content using response.txt. This gives us the raw HTML of the page, which can be parsed in with beautiful SOAP. Now let's use beautiful SOAP to parse the HTML content we have retrieved. We create a beautiful SOAP object passing the HTML content and the parsing method html.parser. The prettify method helps format the HTML in a readable structure, making it easier to navigate and extract data. Once we have the parsed HTML, we can find specific elements within it. To find a single element, we use the find method. For example, soup.title will return the title of the web page. To find multiple elements, such as all paragraphs on the page, we use findAll, which returns a list of matching tags. Beautiful SOAP allows us to extract not just text but also attributes from HTML tags. For example, if we want to retrieve the URL from a hyperlink, we can access the href attribute of an a tag. We can also extract the text inside any HTML element using the .text method. Many websites organize data into lists or tables. Beautiful SOAP makes it easy to extract this data. For example, we can look through all A tags to extract links from a page. Similarly, we can extract data from tables by finding tr tags for rows and td tags for individual table cells. Web pages often contain nested elements, meaning one tag is inside another. Beautiful SOAP makes it simple to access these nested tags by chaining find or findAll methods. For example, you might first find a div tag, then find another div tag inside it, allowing you to navigate complex HTML structures. Once we have extracted data, we need a way to store it. We can use Python lists or dictionaries to collect the information. For more structured storage, we can use the pandas library to save data into a CSV file, which makes it easy to work with later. Not all web pages are static. Some use JavaScript to dynamically load content. In such cases, the data may not be present in the initial HTML, but instead loaded after the page renders. To handle dynamic content, we can use tools like Selenium or Playwright, which simulate a web browser and can interact with pages that rely on JavaScript. While web scraping is powerful, it's important to follow ethical and legal guidelines. Always check a website's robots.txt file to see if scraping is allowed. It's also crucial to avoid overloading websites with too many requests in a short period, so consider using delays between requests. Lastly, always respect copyright and terms of service. To put what we have learned into practice, here are a few mini project ideas. First, create a price tracker by scraping product prices from e-commerce websites. Second, build a news aggregator by scraping headlines from multiple news sites. Lastly, scrap job listings from job boards and save the results into a CSV file. In summary, web scraping is a powerful tool for gathering data from websites. With the requests library, we can fetch HTML content, and with Beautiful Soup, we can parse and extract the information we need. Always be mindful of legal and ethical considerations when scraping, and most importantly, practice by working on mini projects to sharpen your skills. Welcome to this session on APIs in Python. Today, we will explore what APIs are and how they enable software applications to communicate with each other. An API, or Application Programming Interface, defines the rules for interacting with a system or service. It allows data exchange over the internet. Common formats used in APIs are JSON, which is lightweight and easy to use, and XML, which is still used but less common today. Next, let's take a look at the HTTP methods used to interact with APIs. The most common methods include GET, used to retrieve data from an API; POST, used to send data to the API, often to create new resources; PUT, used to update an existing resource; DELETE, used to remove a resource from the system. To work with APIs in Python, we use the requests module. It's simple and easy to use for making HTTP requests. You can install it using pip install requests. With this module, you can send various types of requests, handle responses, and work with APIs efficiently. Let's see how to send a GET request. Here's an example where we retrieve data from a public API. We use the request.get method and pass the API's URL. If the request is successful, we get a status code of 200 and can parse the response with .json. This converts the JSON data into a Python dictionary. Now let's look at how to send a POST request. This method is used when we need to send data to an API, such as creating a new resource. Here we pass data as a dictionary using JSON equals to data. If successful, the server will typically respond with a 201 status code and a newly created resource. APIs usually return data in JSON format. In Python, we can easily handle this using the .json method. Once the data is in dictionary form, we can access it like any other Python object. In this example, we access each post title and print it. While working with APIs, it's important to handle errors. If the response data's code isn't 200, we need to check what went wrong. For example, a 404 means the resource was not found, and a 500 indicates an internal server error. Always handle errors to ensure your application runs smoothly. Sometimes we need to pass query parameters in the URL to filter or customize the data returned by the API. We can do this by adding a dictionary of parameters to our request.get method, which will automatically include them in the URL. Let's look at a practical example where we fetch weather data using an API. First, we need to get an API key from a weather service like OpenWeatherMap. Then we use the API key to request weather data for a specific city. The response contains weather details such as temperature, which we can extract and display. When working with APIs, it's essential to follow best practices. First, respect rate limits to avoid overloading the server. For authentication, use API keys or OAuth tokens. Lastly, always handle errors properly by checking the response data code and responding accordingly. To summarize, APIs allow us to exchange data between systems. In Python, we use the request module to make HTTP requests and work with APIs. JSON is the most common data format, and we can handle GET, POST, and other HTTP methods. Don't forget to handle errors and queries and query parameters when needed. For your practice, try fetching data from a public API and dispatching it. Then create a script that sends a POST request and handles the response. This hands-on experience will help reinforce your learning. Welcome to day 35 practice mini project web scraper or data analysis project. Today we will be combining the skills we have learned in web scraping, data manipulation and visualization using Python libraries such as NumPy, Pandas, Beautiful Soup and Matplotlib. On this day, the objective is to reinforce your understanding of data manipulation, web scraping, and working with key Python libraries. You will choose between two mini projects, web scraping or data analysis. Let's dive into these two exciting options. Project 1 is about creating a web scraper. You will be extracting structured data from a website using Beautiful Soup and the requests module. The goal is to clean and process the data, store it in a structured format, and optionally visualize it to gain insights. Let's explore the steps for this project. Here are the steps for creating your web scraper. First, choose a website with structured data such as an e-commerce site or a weather forecast. Scrape the data using the requests library to fetch the web page and Beautiful Soup to parse the HTML content. Identify the HTML tags or classes that hold the relevant information and extract it. Clean and format the data using Pandas and NumPy. Save the cleaned data in a structured format like CSV or Excel. Optionally, you can visualize the data with Matplotlib, for example, by plotting trends in stock prices or weather patterns. Throughout this project, you will gain hands-on experience with web scraping using Beautiful Soup and requests. You will also practice cleaning and manipulating data using Pandas and NumPy. Additionally, you will learn how to store data in CSV or Excel format and visualize it using Matplotlib. Project 2 focuses on data analysis. In this project, you will analyze a dataset using Pandas and NumPy. You will clean and transform the data, perform exploratory data analysis, and visualize your findings. This project is great for anyone who enjoys working with data to uncover insights. Here are the following steps to follow data analysis. Choose a dataset from sources like Kaggle or data.gov. Load the dataset using Pandas and inspect its structure. Clean the data by handling missing values, removing duplicates, and filtering out irrelevant information. Transform the data by converting data types, parsing dates, or creating new columns as needed. Perform exploratory data analysis using descriptive statistics with Pandas and NumPy. Visualize the data using Matplotlib to uncover patterns, trends, and insights. Finally, summarize your findings and write a report detailing the insights you have gained from the data. With this project, you will gain experience in data loading and inspection with pandas. You will also master data cleaning and transformation techniques. Additionally, you will perform exploratory data analysis using pandas and NumPy and visualize your findings with Matplotlib. To help you complete the projects, here are some useful resources. Beautiful SOAP documentation for web scraping, Pandas documentation for data manipulation, NumPy documentation for numerical computations, Matplotlib documentation for creating plots and visualizations, Kaggle datasets where you can find open datasets to analyze. By the end of this mini project, you will have practical experience in either web scraping or data analysis. You will learn how to clean, transform, and visualize data, and you will create a useful project that you can showcase in your portfolio. Good luck with your project and enjoy the learning process.